All right, we're going to talk about functions today. So, a function is a relation such that each element from a set is matched with exactly one element from another. Okay, so basically what this means is every x must have a unique y. Do you remember the vertical line test? Right, this is how you can determine if something's a function. So the vertical line test says that if you have a graph and you draw a vertical line anywhere on that graph and it touches at only one point, then this is a function. It passes the vertical line test. Okay? A case where it wouldn't, for example, if you had a graph that looked like this maybe, and you draw the line and it touches at more than one point, this is not a function. Okay? So that's all that test says. So what we're going to do, yeah.
What was the horizontal line test for?
To tell if it's one-to-one or many-to-one. We'll talk about that soon in this chapter. Let's determine if something is a function given the equations. So we'll call this example 1. Given the equation, determine if y is a function of x. Okay, let's start out easy. So 2x plus 3y equals 4. Okay, so anytime you do this, you are going to solve for y, okay? And then once you do, you're going to try to decide, is it true that for every x there's just one unique y for an answer? Or you can think about the graph, does it pass the vertical line test, okay? So if I solve for y, I get 3y equals negative 2x plus 4, divide by 3, so negative 2/3 x plus 4/3. Okay, so now I want to think about what exactly I have here. So this is an equation of a line, right? Thinking about a line, will it pass the vertical line test? Yes, right? You can draw a vertical line anywhere, it'll only touch at the one point. So this is a function. Alright, let's take a look at this one. Let's say we have x squared plus y squared equals 4. Okay, so again, you have to solve for y in order to kind of take a look at this. So when I subtract over the x squared, I'm going to write 4 minus x squared here. And then I have to take the square root. Now when you take the square root and you're solving, what do you have to put in front? Plus or a minus. So I get y equals plus or minus the square root of 4 minus x squared. Okay, now let's think about this for a second. If x is 0, I plug in 0, I get the square root of 4, I get a solution of 2. But don't I get plus and minus 2? So for that one value of x, I got out 2 values of y. Okay? Is this a function? No, because for every x there has to have a unique y. Well, there's not a unique one, and there's 2. What's happening here, remember, is this is creating a circle, right? So if you think about that vertical line test, it's hitting at those 2 points because of this plus or minus. So this is important here. Okay, so this is not a function. Okay, but now what if I gave you the equation that looked like y equals the square root of 4 minus x squared? Already solved for y, so now we got to think about, okay, what's going on here. If I plug in 0 again, I get the square root of 4 again, which is 2, but what I don't have outside is the plus or the minus. So what's happening here in terms of the graph means I really am just looking at that top half of the circle. Okay, well, when you draw a vertical line, is it only going to hit at one point? So this is a function. Do you see the difference between these two? Okay, one has that plus or minus. Anytime you see that plus or minus, it's not going to work because it's producing two values of y. So this is a yes. Any questions so far? Okay. We're going to talk about function notation. Okay, so you probably saw this a lot last year, and that's f of x instead of y. Okay, so this is read as f of x. F of x is the same thing as y. Okay, they mean the same thing. This is just function notation. You could also see it like, you know, g of x or f of y or g of t. Like, it doesn't matter. This is just function notation. Okay, so when we see that, we know here is our input, right? In this case, like, x is our input, and then that function evaluates x and then gives us an output. Okay, so that's all that's telling you to do there. So let's take a look at this. Evaluate, let's say we're given g of t equals 4 minus t squared. Okay, and I want to find g of 1. Okay, so when you see this g of 1, this is telling you you're using function notation, your input is 1. So everywhere I see a t now, I have to put a 1, and then I just have to simplify. So I have 4 minus 1 squared. So g of 1 is 3. Notice how I write my answer. I'm not just writing 3, okay? You have to specify, thank you. You have to specify what you're evaluating there. Okay, so you have to write g of 1. If you don't, every time you don't do that, it's going to be minus a half. All right, so make sure you make yourself a note. You have to use function notation. If I asked you to evaluate g of w, what would you do there? What did we do here when I did g of 1? Right. Instead of t, I substituted in a 1. So instead of a t, what do I substitute? A w. So 4 minus w squared is what I get there. That's it. Okay? Sometimes it's going to be a value. Sometimes it's going to be an expression. It's just going to depend what you're plugging in. What if it said find g of x plus 2? Now what do I have to do? I just plug it in, right? Substitute it in. So I'm going to have 4 minus x plus 2 squared. Okay, now, there's this negative on the outside. You cannot distribute that until the very end. Okay, so we have to square this first. So I'm going to get 4 minus and then x squared plus 4x plus 4. I'm going to keep writing that notation so I don't forget to include it in my final answer. Now I can distribute my negative sign and combine like terms. So final answer should be g of x plus 2 equals negative x squared minus 4x. Those 4's are going to cancel. Right? That negative sign has to distribute to every one of those. Okay, do you remember what a piecewise function is? Let's see. So a piecewise function is the function defined by two or more expressions under a specific domain. Okay, so we'll call this example 3. We're still going to evaluate. This time, f of x is going to equal negative 3x, where x is less than 0, and 2x minus 4, where x is greater than or equal to 0. You remember the look of this where you're given multiple pieces, right? It's under a specified domain, so you really have to think about which expression to evaluate in. So if it says find f of negative 1, you have to take that negative 1 and determine which expression to plug it into based on the domain. So x is going to be a negative 1. Well, isn't that less than 0? So the only place I'm plugging it in is to the top expression. So I'm going to do f of negative 1 equals negative 3 times negative 1. So f of negative 1 is 3. Notice the notation I'm using. Okay, what if I asked you to find f of 0? Where do you plug it in, top or bottom? The bottom, because x is greater than or equal to 0. I don't know what it is about these, but every single year on every single quiz and test, students will plug it into both. Okay? It has to go under the specified domain. That part's important. So that's how you determine where to plug it in. So then f of 0 is going to give us negative 4. Everyone okay with that idea? Okay, I'm going to move on. Tomorrow we're going to graph some piecewise, but for now we're just going to evaluate, okay? So, going along with the function notation here, let's look at example 4. Find all real values of x such that f of x equals 0, where f of x equals x to the 4th minus x squared. Once you figure out what the question is asking you to do, the solving is easy. Okay, that's the easy part. It's just trying to determine what you have to do here. So it's important that you're able to figure out what that function notation is telling you to do. What does this mean? So is it an output? Is it an input? You have to think about that. So looking at this, if they want us to take f of x and set it equal to 0, what do I do here with this? Anyone? Does anyone know what it means? Devin?
You just set it all equal to 0.
Yeah, so you're setting this equal to 0. So instead of f of x, you're putting a 0. If this looked like f of 0, what would you do? Plug in 0 for x. You see the difference? Okay, so if we were doing that, we would get 0 to the 4th minus 0 squared. Okay, so that's easy enough. But that is not what this is telling you to do. Okay, this is telling you take the entire function and set it equal to 0 and solve. So I'm going to change that to 0 equals x to the 4th minus x squared. Okay, now I know some of you are thinking, let's move that x squared over and do some division. Okay, that's illegal. Don't do it. Don't do that. What do we have to do here? It's our favorite F word. Factor. Yeah. So what do you got to do? Take out that x squared, that GCF. So I have x squared times x squared minus 1. Okay. At that point, I factored it. Now, this technically can go farther, but I don't have to since I'm solving. Okay, so using the zero product property, we're going to take x squared. We're going to set it equal to 0. X squared minus 1, set it equal to 0, and then we're going to solve. So I get x equals 0, and don't forget you're solving for x squared, so you have to take the square root. A lot of you did this still on your test, even though we talked about it before on the quiz. If you're taking the square root and solving for x, you have to get plus or minus. So x equals plus or minus 1. So final solutions, 0 and plus or minus 1. Okay? Alright, let's try another one. Let's say this time find all values of x for which f of x equals g of x, where f of x equals x to the fourth minus 2x squared and g of x equals 2x squared. Alright, so we're given f of x, we're given g of x. We're told to solve for f of x equals g of x. What should I do to these two expressions? Set them equal to each other. So I'm going to take x to the fourth minus 2x squared and set it equal to 2x squared. And again, you're going to be really tempted to want to move over this 2x squared. Don't do it. Okay, you got to get everything to one side and then you have to factor. So we're going to move over this positive 2x squared, giving us x to the fourth minus 4x squared equals 0. Again, factoring out that GCF of x squared, leaving us with x squared minus 4. If you want, you could factor it further to x plus 2, x minus 2, but again, it's not necessary because we're just using the zero product property to solve anyhow. So take those two pieces, set them equal to 0. We get x equals 0 and plus and minus 2. Everyone okay with reading the notation, either evaluating by plugging in a particular value for x, or having to solve through factoring? Okay, moving on. This next topic you've seen before, recently. And you're going to see it many, 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 many more times, like the rest of the year. Okay? So, find the domain. And now that we've talked about this several times, my expectation is a little higher now. Okay? So, they're going to get harder. Okay? And you're really going to have to think. So we're going to talk about this many, many more times this chapter because this next quiz has it on there, the following quiz has it on there, the test has it on there, and they're just going to get progressively harder. Okay? So we're going to really, really understand this idea. Okay, let's start out real easy. If we're given f of x equals 2x cubed plus 3x squared plus 6. This is a polynomial, right? Is there a restriction? No, no. It's all real numbers. This is a gift. Every time you get a polynomial, it's like a gift. You don't really have to think about it. It's just negative infinity to infinity, both with parentheses. Remember, anytime you write infinity or negative infinity, they get parentheses, okay? All polynomials. Okay, but now I'm going to switch it up a little bit. What if I give you f of x equals 2x plus 3 over 2x squared plus 9x minus 5? You had a problem just like this on your test. Marissa? Yes, you said the denominator equal to 0. Do you understand? Even though there's a polynomial here, okay, in the denominator, it's not all real numbers. Some of you put that. That's not true. If this is in the denominator, remember, we take that denominator, we set it equal to 0, and we figure out the values of x. That's going to make this undefined, okay? So I'm going to take 2x squared plus 9x minus 5, and I'm going to set it equal to 0. And then I'm going to factor it. If it doesn't factor, you'd have to use quadratic formula or completing the square to figure out those values of x. Okay? Luckily for us, it factors. So 2x minus 1 times x plus 5. A lot of you really need to work on your factoring. Okay? I noticed that, you guys were so confident on the test with the factoring, but yet you didn't check your answers. Because if you would have checked, you would have realized that problem was wrong. Okay, so if you're not super confident, even if you are confident, it's always a good idea to check your solutions before you really commit to that. Using the zero product property here, I get x equals 1/2 and negative 5. Now remember, these are the values that x is not allowed to be. Okay, so now you have to think, how do I tell my reader that x can be any number except for 1/2 and negative 5? And this is where we're going to go into interval notation. And it might not say write your answer in interval notation anymore, because I expect you to know anytime we're doing domain, we write our answer in interval notation. So what's the smallest x I can have? Negative infinity. So that's where I start. The smallest number goes on the left. Then I'm going to come to negative 5. But I'm not allowed to be negative 5, so I use a parenthesis. And this is where some of you went wrong. Then you went to 1/2. You can't go to 1/2 yet, right? They got to match. So now I'm telling the reader, okay, you just can't be negative 5, but you could be everything between negative 5 and 1/2, right? All of those values are going to work. Then you're going to jump over that 1/2 again and go all the way to positive infinity. Okay, so this is a rational expression. When you have that, you take the denominator, you set it equal to 0, you're solving for the values x is not allowed to be. Okay, that's how you do those. Okay, what if I give you this? F of x equals the cube root of x minus 6. Brett?
Really quick for B, so
sure.
You don't even worry about the top.
The top doesn't matter at all, because the numerator is not going to give me an undefined solution, right? You're allowed to have 0 in the numerator. It's 0. Okay? How about C? Yeah, it's all real numbers again. This is another gift, right? Any odd-powered root is going to give you all real numbers, because you can plug in anything for x. You can plug in negatives, positives, 0. It all works, okay? So anytime you see an odd root, it's negative infinity to infinity. What if instead it was the square root of x minus 6? Now this is different. There's some rules that are going to apply here. Seth, what do I do here? You can do it. What's got to be true about the square root? What kind of numbers can you take the square root of? Uh-huh. Can you take the square root of a 0? Yeah, because what? 0 times 0 is, everyone? 0. Can you take the cube root of 0? Yes, because 0 times 0 times 0. Okay? So if it's got to be positive and it can be 0, then what do I do with x minus 6? Set it greater than or equal to 0. Okay? You solve it just like in an equation. It's just a linear inequality. So x has to be greater than or equal to 6. What's the smallest value x is allowed to be? 6. So it goes on the left. Does it get a bracket or a parenthesis? Good. All the way to infinity. Okay, so anytime you have an even root, you set it greater than or equal to 0. You might want to be making yourself some notes here if you don't remember every single one of these. These are all easy so far. Okay? Let's keep going with this idea of the square root. So now let's say I have f of x equals 2x over the square root of x minus 6. How is this any different than D? What, Holly? Yeah, it can't be 0 anymore, right? It's a square root, so it still has to be positive. And technically, yes, you can take the square root of 0, but now it's in the denominator. So it's like you're combining the ideas from B and D into one. You have to mesh the ideas together, okay? So we have to take x minus 6 now and just set it greater, whoopsie, than 0. So x is greater than 6. So the only difference between D and E is that we can't be 6 here. So we're going to have a parenthesis at 6 to infinity. All of these ideas we have seen. All of these you should be comfortable with so far. If not, you got a little catching up to do, okay? Now we're going to change it up a little. What if I give you f of x equals the square root of x squared minus 36? Still square root, right? Still could be 0. Still has to be positive. So we're still going to set it greater than or equal to 0. But now, what do you notice about this inequality?
Plus or minus.
It's no longer linear. Okay? You should probably highlight this problem, like major. It's no longer linear. So that means I have to now combine the ideas of last chapter with this chapter. And think about what I know about solving a quadratic inequality. Am I allowed to move the 36 over? Everything has to be on one side. Then what do? You have to factor it. So now this becomes x minus 6 times x plus 6 is greater than or equal to 0. What are these? Critical values. Notice I'm meshing these ideas together. So now I have to test on the number line to figure out which intervals are really in my domain. I'm hoping you remember how to test, right? Plug in values within those intervals. I'm going to test that middle one first. If I plug in 0 here, I'm going to get a negative solution, so this is not going to work. If I plug in like a negative 10, I have a negative times a negative, which is a positive, so this solution will work. If I plug in, let's say, a positive 10, again, I'll get a positive times a positive. This is a true solution. So notice, I cannot just jump right into my interval notation. If you have a quadratic inequality, you have to use critical values. So now my solutions are going to go from negative infinity to negative 6. Do I use a bracket or a parenthesis? A bracket because it's greater than or equal to, and then that's going to be in union with 6 to infinity. Yes?
Wait, you can't just move the 36 over, take the square root, and then say that it has to be greater than plus or minus 6 either way, so
No.
you get the same thing.
No.
Or does that work?
Well, because it would say x is greater than negative 6, and greater than negative 6 would include this interval as well.
I was just thinking about absolute value.
Okay, so you gotta keep everything on one side and then get those critical values. You can't work on both sides of a quadratic inequality. Okay? Now, what if this looked like this now? Let's say f of x equals 2x plus 5 over the square root of x squared minus 4. What, Marissa? Yeah, do you see the only difference here is I'm going to set it just greater than 0 now because, again, I'm in the denominator, so I'm combining the ideas of b and f into 1, okay? So now we're going to do x squared minus 4 is greater than 0. Again, this is quadratic. I have to factor it. I cannot work on both sides. So I get x minus 2 times x plus 2. Right? So that creates those inequalities here, critical values that go on my number line. I have to test my intervals. If you don't know how to test, you really need to see me, okay? And we'll talk it through. Just to save time, it goes yes, no, yes. When I write my answer now, am I going to use parentheses or brackets? Parentheses, okay, because it cannot equal 0 any longer. So negative infinity to negative 2 in union with 2 to infinity. Now here's the deal with these. When we're talking all this through, it makes sense, right? Because we're talking about it together. But when I put these on a test and I jumble them all up, you're going to get confused. This is the main one that students mess up. Okay, you forget about the fact that you have to test the intervals. Okay, so please, please make yourself a special note. Don't forget your critical values there. Okay. Okay, we have one more big idea to talk about. And that is the difference quotient. Okay, this is going to come up again for the rest of the year, and it comes up in calculus all the time. So this is like an intro to the difference quotient. We're just going to evaluate it. When you get to calculus, what happens is you take all the ideas that you've learned here, everything that you've learned how to simplify and solve for, and then you apply it all there. Okay? So it's like we're introducing you to these new things so you don't have to worry about that later on. Okay? You can do the higher level thinking there. Okay, so this is going to continue to come up throughout the year kind of sporadically. All right? And it is difficult to figure out how to set up. Once you get the setup down, the simplifying is okay. It's the setup that's difficult. So we're going to take this slow. So here's example 7. Evaluate the difference quotient given f of x minus h minus f of x all over h, where h can't equal 0, find f of x equals 2x plus 5. Okay, now, first of all, this is the difference quotient that we've been given. It doesn't always have to look like this, okay? It will look different sometimes, but whatever it is, it will be given to you. So, like, you don't memorize this, okay? This will be given to you. Thinking about this, h cannot equal 0. Doesn't it make sense that h can't equal 0? Because that would become undefined. So in our final answer, every single time, we have to make sure that that restriction is still there. So we always write h can't equal 0, or whatever's in the denominator can't equal 0, okay? We are taking this and plugging it in to this. Okay? So here's what I want you to do. I want you to put your pencils down, and I just want you to watch, and I promise I will give you time to write it down. Okay? So I just want you to watch because it's confusing. If you can get this setup down, then this will become a lot easier. Okay? So I always treat it like a 3-part process. So this is like step 1, this is step 2, and then we have step 3 here. Okay? So what this is saying, think about what we just talked about, right? When we were evaluating in example 2, and I saw g of 1, I took 1 and I plugged it in everywhere I saw a t, right? And when we saw like g of x plus 2, I took x plus 2 and I plugged it in everywhere I saw a t. You with me? Okay, so now this is telling you find f of x minus h. So everywhere I see an x, I plug in x minus h. So that's the first step. So I'm going to take this x and I'm going to change it to an x minus h. So I have 2 times x minus h for my first step plus 5. Look what I did there. I took the x minus h and I substituted it in to f of x. So you're going into f of x. Do you understand why I did this? Step 2 says subtract f of x. Well, isn't this f of x? So now here's the part where students always make a mistake. When you subtract this, you're subtracting the entire f of x. So when I plug in f of x, I'm putting parentheses around this whole thing so I can remember to distribute to the 2x and to the 5. Most common mistake made right there. Okay? Step 3 says take that entire thing and divide it by h. So I'm going to take the whole thing and I'm going to divide it by h. I'm going to talk it through and you're going to write it down again. Okay, so I just want you to look at it for a second and see what I did, see how I kind of broke it up. And now let's do it together. So this is saying evaluate f of x minus h. If this said evaluate f of 2, what would I do? I'd plug in a 2 where I saw an x. So now I'm evaluating f of x minus h. Everywhere I see an x, I plug in x minus h. So I have 2 times x minus h plus 5 there. Alex, don't fall asleep right now. I mean, other times is fine, but right now is important. Okay, so plug in that x minus h. Don't forget the plus 5. That's another common mistake, is you'll plug it in, but you'll forget the rest of the pieces. Okay? Now step 2 says, okay, subtract f of x. This is f of x, so I have to subtract the entire quantity, so I have to put that in parentheses. I want to remember I have to subtract the 2x and the 5, so I have to distribute that negative sign to both. Then finally take that whole thing and divide by h. This is the hard part. The easy part is what we're going to do next, okay? So now all we have to do is distribute and start simplifying. You know you'll be correct is when you distribute and you start to simplify and things start canceling, okay? If you see some of that happening, chances are you're on the right track, okay? So you ready to move on? Okay, so everyone's got the setup down. Now let's go ahead and distribute. So I distribute the 2. I get 2x minus 2h plus 5. Now I have to distribute my negative sign. So minus 2x minus 5, all divided by h. Another common mistake is students will forget about that denominator. They'll stop writing the divided by h. A lot of you don't like to show all your work. Start showing all your work on these. Trust me, it'll help you. So do you see here 2x and negative 2x cancel? 5 and negative 5 cancels. These are good signs. Okay, this means we've probably done this correctly. Okay, now what we're left with is negative 2h divided by h. What happens there? The h's cancel because we are multiplying here, right? So you're allowed to cancel. Final answer is negative 2, where h can't equal 0. Notice there's no h left over, but I still have to give that restriction because that's coming from the very beginning, just like we had to give restrictions before. Yes?
I'm just wondering about how you plugged in into f of x minus h.
I didn't plug it into this. I took this and plugged it into f of x. So I took x and I changed it to x minus h. You're taking this and plugging it in here. We're going to do a couple more of these. Okay? Yes?
Will like the h's always cancel out?
No. Sometimes, but not always. Okay? All right. Let's make it a little harder. Okay. So we'll call this 8. Evaluate f of x plus h minus f of x, where all divided by h, where h can't equal 0. If f of x equals 3x squared minus 2x plus 1. Okay. So again, I'm going to treat it like 3 separate steps. This is my difference quotient. Notice it's somewhat different from the last one because the last one was x minus h and now this is x plus h. It can look different. This is just telling you this is what you're going to plug in to your f of x. So I'm going to treat it like 3 steps. Step 1, step 2, step 3. Okay? So here we go. Step 1. Everywhere I see an x plus h, everywhere I see an x, I'm going to put x plus h. So I'm going to have 3 times x plus h squared minus 2 times x plus h, and I'm not going to forget that plus 1. The next step says take f of x and subtract it from this. So now I'm subtracting my f of x. I'm putting the whole thing in parentheses. So minus 3x squared minus 2x plus 1. Step 3, I'm going to take that whole thing and I'm going to divide it by h. The setup is the tough part. Okay, now we're going to start simplifying. So remember, x plus h squared is like x plus h times x plus h. Don't forget those middle terms. So I'm going to have 3 times the quantity x squared plus 2xh plus h squared minus 2x minus 2h plus 1. So that's coming from that pink part. That's step 1. Now I have to subtract all of those terms, so I have to distribute the negative sign all the way through. So minus 3x squared plus 2x minus 1. The entire thing is divided by h. Now I still have to distribute the 3. Okay, I'm just going to do this above here so I don't have to write all this out. So 3x squared plus 6xh plus 3h squared is what I really have going on there. Okay? Are you with me? My hope at this point is that things are going to start canceling. It's going to get easier. So I have a 3x squared, and down here I have a negative 3x squared. Those are going to cancel. I have this 6xh term. I don't have any other xh terms, so I'm just going to write that down. I don't have any other h squared terms. I have a negative 2x and a positive 2x that cancel. I have a 1 and a negative 1 that cancel. And I'm left with this minus 2h. Now this is all divided by h. What do you notice about everything in the numerator? They have an h. So because they all have a common term, it's really like I can factor out that h. So when I factor that out of the numerator, I'm left with 6x plus 3h minus 2, all divided by h. Now that I'm multiplying h times this polynomial here, and I have this h in the denominator, these can cancel. When you have multiple terms and they have different variables, you put them in alphabetical order. Okay? So final answer should be 3h plus 6x minus 2, where h can equal 0. Are there questions? We're going to try one more. Yes?
Wait, h still equals 0 because you're using it?
Correct. Anything else? Yes. Minus a half. Okay. We're going to try one more. You're going to set it up, and then we'll simplify it together. I think this is actually number 85 from your homework tonight. I think. So, you're still doing 85, but you can use this for reference. Okay? So now tomorrow when you come in and I say, do you have questions? You're not going to ask me 85 because you're going to have it right in front of you. I'm going to write that down. Okay. So f of t equals 1 over t. And we're going to evaluate the difference quotient of f of t minus f of 1 over t minus 1, where t can equal 1. Notice this looks completely different from what we did. Talk to your partner. How do you plug this in? Treat it like a 3-step process. What are you going to do? Okay, so you should have it plugged in at this point. Do you have f of t? So that's exactly what you see here, 1 over t. Then you're subtracting f of 1, which is like saying where you see t, you plug in a 1. So now we're going to subtract 1 over 1. And then we're going to take the whole thing and we're going to divide it by t minus 1. Do you have this? Okay, good. That is a good start. Now, do you notice that we're taking what we did last chapter in that algebra review, and now we have to know how to solve this, right? We have to know how to simplify it. So what are we going to do here? Multiply by the common denominator, right? So it's like this is over 1 right now. So between t, 1, and 1, what's the LCD? T. Remember, you have to distribute to every term. So these t's are going to cancel. I'll be left with 1 minus t over t times t minus 1. Right? Nothing cancels in the denominator. You have to multiply t by what's left over, which is that t minus 1. So what do you notice about that numerator and denominator? These look similar, don't they? The signs are off. Factor out a negative. So I'm going to have negative 1 times t minus 1 over t times t minus 1. Because I'm multiplying, I can cancel the quantity of t minus 1. This is not 0. When this cancels, what's left there? Right, that negative 1. So I have negative 1 over t, where t can't equal 1. Okay.